Welcome to this video learning session. When you complete the session, you will be able to create decision tables. In this session, you'll learn about decision tables and why they are important, how to create decision tables, and how to analyze conditions and outcomes. A decision table is a logical structure that shows various conditions and outcomes. Systems analysts use decision tables to analyze and describe processes. In a DFD, each process performs one or more specific functions, such as calculate overtime, check credit status, or apply discount. Depending on the input or conditions, each process produces one or more outputs or outcomes. A condition is a variable with only two values, yes or no. For example, is the customer credit okay? Or is the product in stock? An outcome is an action that results when certain conditions are met. For example, if a customer qualifies, an outcome might be apply discount or ship free. Using a decision table as a guide, a programmer can create code that will produce the right outcomes. In Part 2, we used Microsoft PowerPoint to create the tables, but you also could use Word or Excel or draw them freehand. If a table has a single condition, there are two possibilities, yes or no. Either condition A is present or it is not. So there are only two rules. Single conditions are simple, but when you create a multi-condition table, you can use a pattern to be sure that you show all possible combinations. Here's how it works. With two conditions, the first pattern is YYNN, and the second pattern is YNYN. With three conditions, the first pattern is YYYY, then NNNN. The second pattern is two sets of YYNN. And the third pattern is a series of YNs. Here's a statement that describes conditions and outcomes. If all three conditions are met, both outcomes are produced. Any 2 out of 3 conditions produces outcome 1. If no conditions are met, outcome 2 is produced. Let's analyze the logic. In Rule 1, all 3 conditions are present, so outcomes 1 and 2 are produced. In Rules 2, 3, and 5, 2 out of 3 conditions are present, so outcome 1 is produced. In Rule 8, no conditions are met, so outcome 2 is produced. In Rules 4, 6, and 7, only one condition is present, so neither outcome is produced. The last step is to add the ends to fill out the table. Now we'll analyze a marketing policy. The marketing team at Superstores just announced a customer appreciation policy. Under the policy, repeat customers get free shipping, but new customers pay regular shipping on their first order. A decision table with only one condition is simple. If you're a repeat customer, you're covered under Rule 1. If not, you're under Rule 2. Let's add the outcomes. In Rule 1, repeat customers get free shipping, so we'll enter Y for yes. In Rule 2, new customers don't get free shipping, so we'll enter N for no. Marketing also decided to promote the company's Superstore charge card. The free shipping policy is the same, but now any customer who uses the charge card gets a 5% discount. The table now has 2 conditions, which means 4 rules, because there are 4 possible combinations of yes and no. We can use the yes-no patterns to display every combination. In Rule 1, a repeat customer who uses the Superstore card gets free shipping and a discount. In Rule 2, a repeat customer who doesn't use the card only gets free shipping. In Rule 3, a new customer can't get free shipping but can get the 5% discount by using the card. In Rule 4, a new customer doesn't use the card and gets no incentives. These 4 rules can't be simplified further because each combination of conditions produces a different outcome. A programmer can use this table to develop code. Now let's add a third condition. Marketing now feels that the size of an initial order is important and wants to change the free shipping policy. Now, a new customer can get free shipping on the first order, but only if the order is over $100. The full yes-no pattern has been entered, so we're ready to analyze the conditions and add the outcomes. Let's review the decision table. In Rules 1 and 2, a repeat customer who uses the company card gets free shipping and a discount. In this case, the $100 order size doesn't matter, so the outcome is the same. In Rules 3 and 4, a repeat customer doesn't use the company card and therefore doesn't get a discount, but still gets free shipping. Again, the $100 doesn't matter. The last 4 rules apply to new customers. In Rules 5 and 6, a new customer gets the 5% discount for using the charge card. In Rule 5, the order exceeds $100, so the customer also gets free shipping, but does not get it in Rule 6. In Rule 7, no charge card, but the order exceeds $100, so shipping is free. In Rule 8, not using the card and not exceeding $100, a new customer earns no incentives. But we have more work to do. We need to look carefully and see whether any of the 8 rules are redundant or unnecessary. For example, in Rules 1 and 2, order size wouldn't change the outcome, so we can put a dash in the boxes for that condition. Also, in Rules 3 and 4, order size wouldn't matter, so we can put a dash there too. For a new customer in Rules 5, 6, 7, and 8, each combination produces a different outcome, so each condition does matter, and each rule is unique. The final result is that original Rules 1 and 2 are identical and can be combined into new Rule 1. Original Rules 3 and 4 also can be combined into new Rule 2. After simplification, there are 6 rules rather than 8. In this session, you learned about decision tables and why they are important, how to create decision tables, and how to analyze conditions and outcomes. For more information, you can refer to the textbook or your student study tool. Now it's your turn to apply your skills and check your work. For background information, tasks to complete, and sample answers, go to the Management Information Systems CourseMate at www.cengagebrain.com. Select this text and navigate to the video learning sessions. Thanks for attending this video learning session.